Okay, so welcome to the final session of the day, which is on multi-messenger astronomy, prioritization, and something else, coordination. There we go. I've presented, I've done the panel, and now I'm chairing, so I've done my three. So our first up is our invited speaker for this session, which is Judy Racusin from NASA Goddard, who's going to be telling us about GCN.
Great, thank you. Well, I want to start. I actually have too many jobs, so I'm going to start before I get to GCN. I recently, a few months back, started working on part of the Roman Project Science Office and the Deputy Operations Scientist. And I double-checked this morning with Julie, but the project is allowed to publicly say that launch is no earlier than September 7th. There was a lot of sort of being coy about that this morning, but we have not announced that via our comms yet, like publicly, but that is the date the project is planning to, September 7th, no earlier than September 7th, barring launch delays and weather and whatnot. So anyway, I just wanted to put that out there. And also, if anybody wants to talk about Roman Project Science, I might not know the answer because I'm fairly new, but I'm around. So I'm here to talk about GCN, the General Coordinates Network, and I also am going to have a slight deviation into VO event because I'm also chair of the IVOA Time Domain Interest Group at the end. So first I wanted to highlight the GCN team. Those of us outlined in red are here at this meeting. We're happy to talk to you about GCN if you have any questions or ideas or input. But this is our GCN team. And we have, there's a link to, actually this comes from part of our documentation. So what is GCN? So first I want to ask, how many of you have ever used GCN? Okay, that's a lot of hands. I'm happy to see that. Or interacted with it in some way or other. I think it was in Matthew's talk earlier, he was saying the first broker was in 2006. I would actually argue the first time domain broker was GCN in 1993. Whatever, it's the internet and the world has changed a lot since 1993, but GCN in its many incarnations, starting with Bacadine, and it has had many names. The G has changed and evolved over the years. Started out serving the gamma ray burst community and other high energy gamma ray transients, adding gravitational waves, neutrinos, and I'll get to later, we're actually serving a number of different kinds of transient alerts. It's enabled many seminal breakthroughs in astrophysics. Growth, especially adding gravitational waves, really meant that the GCN that was created in the 90s and did have some evolution, but needed to evolve. And about 5 or 6 years ago, we started working on the modern evolution of GCN, which is the General Coordinates Network, which is what I'm going to focus on. I have a brief timeline here, going from the very first system of GCN involved a tape recorder and a phone and worked about as well as you can imagine. Email, computer socket, pagers, VO event, many distribution methods. And I also want to highlight Scott Barthelme passed away last month. Scott was the founder of GCN. He was, if you interacted with GCN at all pre-say 2022, you interacted with Scott because he edited everyone's settings and did everything very manually. Thankfully, we don't do that anymore because I would have to do it. I still do maintain GCN Classic, but luckily most people are unsubscribing these days from that because they're using the new system and not adding or editing subscriptions. But we miss Scott, and he's responsible, I think, for a lot of how all of time domain astronomy, how it evolved and from what he originally envisioned, and he really did serve many different communities. Okay, so GCN has two different types of data products. We have notices, which are machine readable, machine written alerts. We're very familiar with that. We've been talking about that, at this meeting, and that is the standard these days because there are too many things to handwrite everything. We also serve GCN circulars. As of this morning, there were more than 44,000 of those since 1997. These are human written observation reports, free-form text, and they're citable, and they automatically end up in ADS. These work for communities that have a low rate of discoveries and follow-up. This is not really a practical model in the the Rubin or Roman eras, or where the rate of transients is so high that sending an email is insufficient. But it is still very important to certainly the gamma ray burst community and gravitational wave follow-up and others. We introduced the new GCN in 2022 with our new website. GCN has all the bells and whistles you'd expect of a modern website. It's self-service, it has open standards, it's all open source, and that's our link to our GitHub organization. highly available, secure, and I think in general has been serving the community well. In addition to our classic GRBs, Saf gamma repeaters, and then for the last decade or so, gravitational waves, we serve low and high energy neutrinos. So low energy neutrino alerts like SNOOS and Super Kamiokande, high energy like IceCube, and we're working with KM3net to add X-ray transients from missions like Einstein probe, SPOM, and we've recently added FRBs from CHIME and DSA 110. And this connects thousands of both sort of discovery and follow-up observers, and I'd say our community has been, our users have been growing. The number of users has been growing a lot since we introduced the new system. The technology behind GCN, as well as all the systems we've been hearing about today, is Kafka. GCN Classic, in its infancy, because there weren't standards when it started, distributed 3 different data, all alerts in 3 different data formats: VO event over the VO event transport protocol, text format over email, and a binary over a custom socket connection. And it did all the conversions, sometimes imperfectly, between all of these different data formats. In 2022, when we launched the new GCN, we introduced GCN Classic over Kafka, which is all of those same alert formats, but available over Kafka and email, and we are still supporting that, although all new missions are using the new GCN, which involves JSON format notices that we are distributing over Kafka, although we do want to add some sort of email version of that, although we're going to need to strip out the attachments. We have completely overhauled circulars in the new GCN. We did a at a specific point migration in April 2023, where we shut down the old program essentially and closed the archive, and then transferred everything to the new archive and new distribution and management through that. There are self-service management of subscriptions, hooray, because for a couple of years I had to manage everyone subscribing, filling out a web form, and then editing people's subscription in the old system, which was ridiculous. So I'm glad we're past that. We have a peer endorsement system for new submitters, kind of modeled after archive, and that's been working well. We've had no issues. Email and Kafka notifications are distributed in parallel to all users within seconds. That fixed an old complaint of GCN Classic. Circulars run on highly available distributed cloud services. There's a nice web form that Leo put a lot of thought and creativity, including in that template there, into designing, and it supports Markdown. We added a big new feature, which took a lot of actually under the hood work last year, that Corey over in the corner that she built, which was viewing circulars not just in reverse chronological order, but by astronomical event. So there's an event view, and every circular gets an event ID that's automatically assigned. And then if an object gets more than one name, our moderators, who are me and Vidushi, can then go and make event groups and group those together so they appear together in the archive. This plot, I think I updated last about a month ago, but you can see since we introduced the new GCN circulars, the rate of circulars has certainly increased a lot. 04 happened in there somewhere that might have had some impact, but I think it'll hold even beyond 04, the trend. So summarizing, these are all of the different data products and transport methods and where we're going in the future. So GCN Classic is now what we refer to the old, so how we refer to the old system, which had the text, the VO event, and binary that were available over those custom formats. We've announced that we're retiring VO event transport protocol next week. We just need to do this. I think pretty much everyone is willing to switch to Kafka, or they better be after April 6th, but we can't maintain that system because it doesn't meet NASA security standards, but everything is already available and has been available over Kafka. JSON notices over email we plan to add. Circulars are available by classic email, but also over Kafka. And I think at some point in the future, we'll eliminate the socket connections. We just need to nudge, people don't want to change their pipelines, but nudge people to switch to Kafka. But since all new producer missions are utilizing Kafka, that's the only way to get their alerts. And we're hoping that that's enough of a carrot to get people to convert. So I mentioned the GCN JSON notices. For better or worse, we decided to create our own new format of alerts and our own new standards. We call this the unified schema. And this is a set of core schema building blocks that a producer can build notices out of. They don't have to use all of those schema components, but they can, and they can use any subset, and then they can also add custom fields. And the core schema have also evolved as we've added new producers, and we add fields that we think would be useful, not just for the one new producer mission or instrument who is using those data products. There's using those parameters, but it might be more generally useful. Vidushi's done a lot of the work on this and done a lot of the interaction with the producer teams as we're onboarding them. This is all available via a Git repo, but also an interface we call the schema browser that draws from that. It's on our website. This is a list of the sort of GCN JSON notice producers. I put Igwin in its own little box because they don't use GCN JSON. They do use the JSON format that was developed. This is LIGO Virgo Kagra. That was developed around the time that we were also developing the unified schema. So we distribute those JSON files, but it doesn't adhere to the same format. We've already are producing new GCN notices from all the other experiments in this box. We're pretty close on the ones in the middle, and we've had some preliminary discussions and in various stages of developments of the ones on the right. This is most of the GCN Classic producers are working on converting to the new format notices and distributing entirely over Kafka, no longer using, well, at least maybe in parallel to what's going to GCN Classic and not reliant on it. We are working on a number of new developments. A big component we're doing right now that'll enable some other things is our handling of group and topic management and permissions. This likely will largely be not really, it'll be transparent to users, but it'll enable us to do things like sending those JSON notices over email, especially if there are topics that are maybe private topics. And that's something that the notices by email, if there's been requests for, something that I think will be useful broadly. Another thing we're working on is GCN circular split by event type. So say you only care about gravitational waves, you could subscribe just to the gravitational waves, all of them, or gravitational waves and GRBs, or whatever is interesting to you. And we'll make it so that this is possible to sort of distinguish in the archive, as well as you could subscribe to just a subset via email, and there'll be separate sort of sub-Kafka topics. We also need to build a complete notices archive. This is challenging given all of the very different data sets we have from archivally, and also easier with the new notice types, since at least you have some common fields. But this is a challenging thing to put together, but it's something that we have promised to do, and we're working on building, or we will be hopefully soon. We're also have been even having preliminary discussions of expansions into new field. These are buzzwords these days, certainly at NASA, of things we need to prioritize. But we've had some preliminary discussions with groups doing things like planetary defense, which is near Earth objects, and also space weather. So we were asked to think about or address some questions. And I took two of those out of Ryan's list. And I don't know that I really answered them because I'm asking additional questions. But one is, how do we optimize transient discovery with multi-wavelength and multi-messenger alert streams? And so I think we need interoperability. I mean, we've talked a lot about that today. And I think there's still a lot of work to do there. We need easy ways to compare data. We need, some common tools that have community, involvement in maintaining and developing. And potentially maybe go back to a common alert standard, which is what I'm going to go into next. And not really even answering the question, but what physics of stellar explosions, et cetera, can be revealed with rapid observations. But I think, this is a more technical, just kind of discussion meeting, but how do we quickly figure out and identify and associate counterparts with especially poorly localized gamma ray bursts, gravitational waves, neutrinos, and be able to collect detailed light curves and spectra, because that's how we do the physics, is we need good observational data sets, multi-wavelength data sets that have good time cadence and that we collect on these rapidly fading objects. So anyway, posing these things may be more for the discussion. So moving on into, in my last 5 minutes, into alert standards. And I'm going to use standards in quotes because I think has been a divergence of alert standards. We've heard about what Ruben is doing with Avro, which makes sense. There's so many alerts. It has to be compact and binary and efficient. And we've heard that the Rapid team is adopting something similar. The Gravitational Wave Network developed their own JSON, as well as there is an Avro version distributed via SIMA that includes, I mean, I'm not as familiar with it, but it includes some sort of embedded schema. GCN JSON I've already talked about. GCN Classic was never standardized, but the source code, which I would not ask anyone to dive deep into, it is 30 years of development, let's just say, without version control. It had converted, spends a lot of the code is converting between VO event and the text format and the binary format. And the text format was totally non-uniform. And so part of what GCN JSON, we were trying to at least address some of that. So use the same term for RA for different notice types, for example. And VO event, which I think has kind of become a little bit of a bad word in a lot of transit communities, because it in 20 years ago was great. There was a standard, people started using it, but it didn't necessarily evolve with where technology and the astronomical community has gone. So breaking down VO event a little bit, there are 3 components. There is the transport protocol, known as VTP, the VO event transport protocol. There's the data serialization, and VO event uses XML, which is kind of painful, and the schema, which is what's inside the alerts. So here's a little history of VO event from a very biased perspective, which I admit I was only very recently, invested at all. But it was developed in 2006. That was when the first version came out. I know that GCN Classic adopted it and started distributing in something like 2012. And like you, I had my complaints, and I was invited in 2024 to speak at 2 IVOA interop meetings, which are the international interoperable meetings between all the different virtual observatories. And I spoke in a session, it was a remote, and I know Eric Belm was in the same session, and we both explained, I explained why GCN didn't want to use VO event anymore, and he explained why Ruben was going that way. And I said VTP is insecure, and the Python implementation is not being maintained. The XML is inefficient and hard to parse by humans, much less code. And the VO event schema are so generalized and sprawly that it was actually hard to do kind of comparisons between different data. So then, to my surprise, IVOA said, okay, VTP, done, it's dead, let's use Kafka. And I was like, okay, that's cool. We could be serialization agnostic, XML, JSON, whatever else you want to use. Okay, so that's 2 big complaints, and they're open to evolving. So then I somehow got talked into becoming the time domain interest group chair of the IVOA, tasked with defining the next generation of VO event. I will admit then 2025 happened, and it was a rough year at NASA, and I haven't made much progress on this, but I'm trying to do better, and I'm trying to engage with different communities who might be interested in this. Yeah, this is an opportunity to develop a new version of VO event, and I'm hoping that all the work that we did developing, for example, the GCN JSON could be, maybe some of that could be useful there. There is a slight, so VO event 2.0 is the current standard. VO event 2.1 is in its final approval stage. This has some minor changes for uses enabling solar system objects. But it does, one of the things they did add is that you can specify a Kafka endpoint. It doesn't have to be just VTP. So VO event 3.0 is an opportunity, maybe. And I think especially with the sort of sprawl of alert systems, of brokers, there could be some use in at least having a way to come back to a point where people could just have one type of alert that they could ingest and make everyone's code much simpler. So to summarize, no more VTP, we can use Kafka, no more XML unless you want to use XML, and the schema could evolve. So what did the schema look like of VO event? And this is not, I don't know, see, it depends how open the IVOA is to change, but like it did have this who, what, where, when, how, why format, and then there were parameters within that. This is up for negotiation, but I think there's something useful there. But I do want to pose a question, for people to think about, or maybe for the discussion of, why hasn't this continued to serve our communities, and how could it? Could VO event evolve to serve TDAM communities again? I think there's lots of good reasons we have all deviated, including, too many hats, but, including GCN. But VTP and XML are no longer the crux of that because they're willing to evolve. We are willing to evolve. Everyone's developing their own parsing tools to combine data from different alert systems. We could make that easier. I think there could be tools like maybe building things around an AstroPy formalism. So you read in something and your units all get converted magically, and that would make life easier. So I'd like to put together some sort of working group. If you're interested, please come talk to me. But I'm hoping to gain some momentum with this before we get sort of completely solidified in everything we're doing. And I'm out of time, so I'll stop there. Thank you.
So as one of the original authors of VO event and also a former TDI chair, I heartily endorse and
well, I hope you'll be involved in help us.
and Godspeed. Okay. We have time for questions. Jakob.
It's amazing that you're going to fix VO event.
I'm going to try.
This is, I mean, we talked about this for a very long time. I think and of course the schema is the really tricky part in there. And you mentioned the questions are nice, but it's so vague, it's uninformative. And I think the reason that one of the reasons is that it's very hard to make that a meaningful thing. But maybe with data models, it would be wonderful if it works. That's what I can say. And I think
it's a good point for this. That Babylonian tablet I had at the start, you can put that in the same VO event schema. I mean, we ask the same things of events. So I think conceptually it's there, but
yeah, I mean, the implementation of the schema is absolutely the hard part. I mean, I think when we tried to reinvent a new one with GCN, I learned that, and it keeps evolving because we hadn't thought of everything for every source type. So yeah, that's where the challenges are.
Other questions for Judith? Okay, let's thank Judith again.